Okay, I have two integrals on the spot. The first one is the integral of 1 over 1 minus x squared in the parentheses and then raised to a 3/2 power. And then for the second one, we have this x on the top and then the same denominator as the one over there. Which one do you guys think is easier? Well, of course, pause the video and do the easier one first. Alright, so I will show you guys that this right here is easier, right? So you see that if you take u to be the inside, the derivative of this, well, we have the negative 2x, and we have the x on the top to help us out. So I'll go through this real quick. First of all, let u equal to the inside, which is 1 minus x squared, and then differentiate both sides, we get du equals this right here, negative 2x, dx, and then let me show you guys the cancellation. I will divide both sides by negative 2x, so I can isolate the dx, and we get du over negative 2x. And now we take this integral to the u world. This is the integral, on the top is x, and then inside is the u, and then we have the 3/2 power, and the dx is this. So we can put down du over negative 2x. And the beauty of this is that the x on the top can be cancelled out with this x on the bottom. That's very good. And then we have 1 over negative 2. It's just a constant multiple, so you can write that on the outside. And then you have the integral. And we have to integrate 1 over u to the 3/2 power in the u world. We will look at this as u to the negative 3/2 power, and then let's put down the du. And then, of course, we can just do the power rule, but do it backwards. Right here, we add 1. Negative 3/2 plus 1. We get negative 1/2. And then look at this new power divided by this, you get negative 2 over 1. Right? Divided by the new power, and then you have this. And then from here, as you can see, negative 1 over 2 and negative 2 over 1, they cancel, and then you have u to the negative 1/2 power. That's it for the integration step. And of course, write this down a little bit better. This is 1 over square root, and the inside is u, and the u is that. So I put down 1 minus x squared, and we are done. Plus c. This is it. Okay. For this one, the x ran away. It's okay. We can find somebody else to help us out. So, look at the inside. We have 1 minus x squared. We can take x to be sine, because we know 1 minus sine squared theta will give us cosine squared. So, I will take a look of the x right here, and I will begin by letting x equal to sine theta. And then from here, we do our usual business. We'll just differentiate both sides so I can get the x, I can get the dx right away. And this right here, the derivative of sine theta is cosine theta, d theta. And the truth is, you could have also let x to be cosine theta. That will also work, but if you differentiate cosine theta, you end up with negative sine theta. Nobody likes negative derivatives, so that's what we usually do with this. Okay, to continue, we see that this is the integral. And then we have the 1 on the top over, this is 1 minus x is sine theta, and that's the square. And then we have the theta. And then we have this to the 3/2 power. And then we have the dx, which is cosine theta, d theta, like this. And now, cancel things out a little bit. This right here, as we mentioned, it is cosine square. So I'll put this down as cosine squared theta, and of course, you raise that to the 3/2 power. This and that, you end up with cosine to the 3rd power theta, right? Because 2 times 3/2, you get 3. Well, we can cancel things out a little bit. You see, this and that can be cancelled out, so you have the 2 right now. So this is very nice. You just need to integrate 1 over cosine squared theta after all the cancellations, d theta. Oh, by the way, there's finally sine, but the sine is but this is 1 minus sine squared theta, in case if you cannot see. Yeah. Anyway, this is actually really easy to integrate. Why? Because this is just nicely equal to secant squared theta. So this is the integral of secant squared theta, and as we all know, the derivative of tangent will give us this, so the answer to this is just tangent theta. But we are not done yet, because we have to go back to the x world. Look back to this. We know that sine theta gives us x, which is the same as x over 1. And I'll draw the triangle, so that way I don't need to use too much identity. And then in case if there's anything else, the triangle will do the work for us, right? All right, so we have sine theta, put the angle here. X is the opposite side, which is here, and then the 1 will be the hypotenuse. And then to figure out the adjacent, which is, you take the square root, and we do the hypotenuse square, which is 1 square, and then minus the other side square, so 1 square minus x squared in the square root. And then tangent theta, by looking at this triangle, is just the opposite over the adjacent, which is just this over that. So you can see that this is really interesting because we get x over square root of 1 minus x squared, like that. And we are done. Put plus c like this. Take a look how cool this is, because originally this right here, the x ran away, but now the x is back. Earlier we had this x, but the x is gone right here. So cool, isn't it? Anyway, if you guys are new to my channel, be sure to subscribe. You guys can find a lot more math lessons and also more math tutorials, a lot of math stuff for you guys. Right, that's it.